Hello everybody, and welcome to example 2 on page 28 of the workbook here. Let's read this question together. So they're telling us that the temperature in a living room is given by T equals f of d degrees Celsius, where d is the distance away from a fireplace in meters. Okay, now what's interesting about this question is they don't give us a formula for the function, and they also don't give us a graph for the function. So we're thinking entirely conceptually here. Even though we don't have a graph, we can maybe think a little bit about what a graph might look like, just roughly speaking. So I'm going to try to sneak in a pair of axes here. So we've got our input variable is d, that's distance in meters. And then our output variable is t, okay, that's temperature in degrees Celsius. Okay, my question to you is, what do you think would happen to the temperature as our distance away from the fireplace gets bigger, as you move away from the fireplace? Well, logically, it seems like the temperature in the room should decrease. So, roughly speaking, whatever this function looks like, it's probably going to be decreasing. Temperature is going to go down as distance goes up. Maybe we can use that to help us to answer the questions that were being asked here. All right, so starting with part A, they ask us, what are the units of f prime of d? Okay, well, remember, f prime of d is the slope of a tangent line geometrically, so its units should be the units of rise over run, degrees Celsius per meter. Okay, so we could say this, since d is measured in meters, and T in degrees Celsius, the units of f prime of d should be degrees Celsius per meter, rise over run. All right, and then the next question, they're asking us, do we think f prime of d is a positive or a negative number? Okay, well, again, if you think of just taking a point on this graph, okay, and f prime of d is the slope of a tangent line, you can see that that slope should be negative, and that comes from the fact that we sort of reasoned out that temperature should be decreasing as distance increases. Okay, so let's put that into words. Because T likely decreases as d increases, f prime of d should be negative. Okay, we're getting a negative slope for our tangent line. Okay, so I think we've answered part A. Let's move on to part B here. So they would like us to give complete sentence interpretations of the meaning of the following two statements in the context of this problem. Okay, and we'll start with number 1 here. So they're telling us that f of 2 equals 25. So to get started interpreting that, let's remind ourselves which number is which here. So 2 is being substituted into our function, so that must be a value of d, whereas 25 is an output, that must be a value of T, the temperature. So we can put that statement into words by just saying that when we're at a distance of 2 meters from the fireplace, we are getting a temperature of 25 degrees Celsius. All right, let's see if we can write that down. The temperature is 25 degrees Celsius, okay, at a distance of 2 meters. From the fireplace. Okay, and then we come to number 2, and there they're telling us that f prime of 2 is equal to negative 1.4. How would we interpret that statement? Okay, well, we might start by reminding ourselves that the unit of the derivative, we actually calculated that up in part A, is degrees Celsius per meter. Okay, so this minus 1.4 is degrees Celsius per meter. Notice that that's a rate of change. And so statement number 2 is giving us a rate of change. Okay, how fast the temperature is changing as we move away from the fireplace. All right, so in words, we might say something like this. Okay, at a distance of 2 meters from the fireplace. There we're just noticing that that's kind of our starting point too. The temperature decreases by about 1.4 degrees Celsius per meter that we move away from the fireplace. Okay. So there's an explanation for part 2, and we are ready to move on to the very last part of this. Okay, so this is a new type of a question. I don't know that we've looked at one like this before. They would like us to use the information from part B to estimate the temperature at a distance of 2.5 meters away from the fireplace. Okay, now I want to just draw a picture of this, okay, because this might help us. So we have some information about what's happening at a distance of 2 meters away from the fireplace. In particular, if you look up at part B, they tell us that right at 2 we have a temperature of 25 degrees Celsius. I'm going to just draw that into our picture so that we can see it in front of us. And they're asking us what would happen if we moved a half a meter to the right over to 2.5. Could we figure out a reasonable estimate of what the temperature should be there? Okay, well, how do we do that? Well, we need to think about how fast the temperature is going to decrease as we move between 2 and 2.5 meters. And the key to doing that is looking at our derivative, okay, up in part B. Okay, so if we sort of write that in words, okay, f prime of 2 equals negative 1.4, that would be saying that we're getting a 1.4 degree temperature decrease for every 1 meter that we move away from 2. Okay. For every 1 meter moved away. Okay, that's what those units of degrees Celsius per meter mean. All right, so how far do we move when we move from 2 to 2.5? Well, that's a distance of 0.5 meters. Okay, so if the statement that we made over here to the right tells us that we decrease by 1.4 degrees Celsius for every 1 full meter that we move away, how much would the temperature decrease in a half? That in 1/2 of a meter? Kind of makes sense that we should get 1/2 of the temperature decrease of 1.4. Okay, so what we could do then is to say that the temperature that we're looking for is just going to be the 25 degrees Celsius that we started with. Okay, so the temperature that we started with here minus half of the 1.4 that we've got there. So, okay, again, the logic is if we had moved a full meter away from 2, we would expect a 1.4 degrees Celsius decrease, but we only moved a half a meter, so we would expect to get half that decrease. Okay, and if you do the calculation here, that's 25 degrees Celsius minus 0.7 degrees Celsius. That's going to give us an estimate of about 24.3. Okay, and that would be our answer to part C. Okay,